All right, everybody, here I am. I'm gonna show you, I'm all by myself in the lab, and I'm gonna show you how to do lab 10. That's the oxidizing strength of the halogens. And right now, what I have to show you is I've got the 3 halogens dissolved in water. So, I'll show you what they look like. Right, so right here, I've got in this test tube, this is chlorine water, that's bromine water, and that's iodine water. And just as a reminder, remember that there's a difference between saying a halogen, those are the neutral diatomic elements, and saying a halide. So those are your anions like Br minus, Cl minus, and I minus. So be aware of the difference between talking about a halogen and talking about a halide. Because for this lab, we're going to be working with both the halogens and halide salts of those halogens. So the first part for this lab is we need a way that we can visually tell apart the 3 halogens, Cl2, Br2 from I2. And the first thing that I want you to ask yourself is I want you to ask yourself whether you can easily tell these apart. So if these test tubes were not labeled, could you easily tell this apart? And, you know, at first, some students will tell me yes, because this one's darker and that one's lighter. But if they weren't labeled, how would you know that this is just not a more concentrated version of that? Same thing with chlorine water, which is the lighter one. So the first part of this is I'm going to take this and add hexanes to it. So hexane, that is a non-polar solvent. So hexane and water don't mix. And once I do that with, this is the chlorine water test tube, I mix it a little. Notice that I get 2 layers there. So this is like oil and water, right? So what I want you to write down in your observations is the color of this layer. And again, this is chlorine water. So CO2, take a look at what that layer looks like. So let's now do that same thing for Br2. So Br2, I'm going to take Br2, mix it. And now tell me what the hexane layer, which is the top layer, something that I needed to mention for the last one, which is the top layer, what color is that? So I'm going to bring it closer to myself. I'm doing this with my phone from the lab, so bear with me on this one. So record the color on that layer, and finally we've got I2. Right, so now record the color of that layer as well. Right, so hopefully you can see, let me get some paper towel so you can see the color of it. So here's a better view of that color. So that top layer, which is your hexane layer, this is for I2. So what this lets us do, so once again, here's Br2, you want that top layer, right? It's not, the 2 layers is not as clear when I put the white under it, but you can see the color better. And then there's chlorine. And what this lets us do is, now if I compare those 3 layers, and again, now we're just looking at the top layers here. If you compare those 3, it's very easy to tell apart looking at the top hexane layer, which one's chlorine water, that's the clear colorless one, which one's bromine water, right, that will be this one, and which one's got the I2, iodine water. So now I'm going to go ahead and proceed with part 2 of this lab, which is we're going to do a reaction between a halogen and a halide salt. And for test tube 1, here I've got 1 milliliter of 0.1 molar sodium bromide, that's already in here. And these labs are quantitative, so when I measure this for 1 milliliter, I just roughly, 20 to 25 drops, and then match the heights for the rest of my test tubes. So when you're being qualitative, you don't have to waste a lot of time measuring out 1 milliliter with your graduate cylinder each time. Now, now to test tube 1, I'm going to add approximately 1 milliliter of chlorine water. Shake it. Right, so I'm using the low-tech version of the vortex mixer because those vortex mixers are so loud. So you're not going to hear me talk if I try to do this with the vortex mixer. So record the observation there. I haven't added the hexane yet. I'm going to add the reagents to all of these test tubes, and then I'll add the hexane. Now I've got test tube 2. This one has 0.1 molar sodium iodide in it. And I'm going to go ahead and add about a milliliter of chlorine water to that one. So here's test tube 2. And note here, so you know there's something going on here because there was an immediate color change, and now this turned cloudy, so it's also a precipitate forming here. We'll have more to chat about that once we add the hexanes. Now moving along, test tube 3. Test tube 3, I've got some sodium chloride in here, and to this, I'm gonna add some bromine water. So I've got my glass stopper. Whenever you're working with a bottle with a glass stopper, it's important not to touch the part that's in contact with the chemical, especially if you're working without gloves like I am, because you don't want to get that chemical on your hands. And it's also important not to put the stopper into the lab bench. You either want to use a paper towel or put it upside down to make sure that you don't contaminate it with anything that might be on the lab bench. So I'm going to take the bromine water here. And again, this is test tube 3. That's what you're going to record in your observations for this lab. And I'm adding about a milliliter of bromine water there. And I'm going to mix it the low-tech way. I'm going to move along to test tube 4. Here I've got some 0.1 molar sodium iodide. And I'm going to add a milliliter of bromine water to that. Mix it, move on. Right? Note that here, right, there was a color change, and there's also a precipitate being formed because that's turning cloudy, as in not see-through. Okay, so I'm done with the bromine water there. Make sure I put the stopper back, and now finally moving on to test tubes 5 and 6. These are the ones that require iodine water. And I've got test tube 5 right here. Test tube 5, I've got about a milliliter of sodium chloride in there, and to this I'm going to add some of the bromine water. Right? So that's for you to look at. And now I've got test tube 6. I'm going to add about a milliliter of iodine water to that. So now I'm ready to add the hexane in, and I'm going to do that to all the test tubes, see if I can do it while I'm videoing it, and you can kind of see it. And again, your instructions say add about a milliliter. I'm just adding enough so that you can't see what I'm adding, so that I get a layer on top there. Remember that the top layer is the hexane layer, and the bottom layer is the aqueous layer. So now I've done that, and I'm going to mix the test tubes one by one and let you look at them so you can record your observations. Remember that you're looking at the top layer here. So the top layer there, let's continue mixing this. See if you get a good color out of it. Right, so let me get my contrast there, right? So record what color you think that top layer is. That was test tube 1. Now moving along, test tube 2, forgot that I already added the hexane, right? So now record what color you see that layer as. Test tube 3. Remember, we're looking at the top layer. Record that color for test tube 3. Moving along, test tube 4. There's test tube 4. Test tube 5. This one I'm having to mix real well because there's not so much of this halogen present, and I'm going to make it evident for your observations what this is or what it should be. Okay, there, much better. All right. So record the color of that top layer. And then last one. Again, I'm having to mix this one real well. And the trick for mixing is, so essentially the low-tech vortex mixer is you want to hold on to the mouth of your test tube, pretty strongly so you don't accidentally drop it. And then you kind of hit it with the bottom of your hand, and that creates kind of like a vortex, right? That's enough that you can see what color that is. So record the observation of that top layer as well. Now I'm going to go clean up. These all have halogens, so they all need to go in the halogenated waste. Halogens are actually very toxic for marine life, and so we don't want to put any of that down the drain. So I'm going to go dispose this in the halogenated waste, and then I'll see you again shortly for telling you how to interpret your data. So thank you for watching. and we'll be back.